Good morning, engineers. In this video lecture 5 on MATLAB, I will be explaining certain features of MATLAB. For example, how to set breakpoint, how to set conditional breakpoint, how to access mic and speaker, etc. Also, if you don't, I am using audio toolboxes. Audio toolbox. If you don't have the audio toolbox, you can still use all the codes, whatever I will be dealing. All you need is a VLC media player or something to play audio file and some recorder to record audio files. So using that, without using that audio toolbox, you can use MATLAB. Audio toolbox is not exactly a must, but if you have that, that will make your job easy. So I recommend everybody have access to audio toolbox. This is an example of a MATLAB code, a transmitter. Sorry, this is an example of a transmitter code I have written in MATLAB. One of the things you can see from this code is I will show you. This RNG default, as I said, RNG default. This instruction RNG default. This resets the random generator to default value. So, as I said, this RNG command, whenever you uses multiple algorithms to test the same different performance, you want to have the same input data. For example, I will explain once again. You are generating some PRBS sequence x equal to plus 1, plus 1, minus 1, minus 1, minus 1, plus 1, minus 1, plus 1, plus 1, minus 1, minus 1, minus 1, minus 1, etc. This is one sequence you are using for algorithm 1. If you don't initialize the using the RNG default command, next time you may deal for algorithm 2. Instead of this x equal to, you may have plus 1, minus 1, plus 1, plus 1, minus 1, minus 1, plus 1, minus 1, plus 1, minus 1, minus 1, minus 1, which is different from you use for algorithm 1. Because if you don't initialize it, the random generator will, these are two BPSK sequences. It uses different input digital bits. They are not same. You can see plus 1, plus 1, plus 1, minus 1. They are not same. So algorithm 1 and algorithm 2 performance may be different. You are not sure whether algorithm 2 has improved compared to algorithm 1. You are not sure. Algorithm 2 better than algorithm 1. You are not sure if you don't initialize the same seed. But if you initialize the same seed, so if you generate so many random plus and minus 1, if you reinitialize using RNG default algorithm 2, then after RNG default, x equal to, the same thing will come. Plus 1, plus 1, minus 1, minus 1, minus 1, plus 1, minus 1, plus 1, plus 1, minus 1, minus 1, minus 1, minus 1. Both are same. So you can compare the performance of algorithm 1 and algorithm 2. If you don't initialize for algorithm 2 the same default using default, These inputs are different. So this may cause some problem. You are not sure. So make sure that that is you ruled out. You want to rule out the possibility. So better initialize with the same seed. When you compare two algorithms, use the same seed. So you initialize the default value so that the random sequence inputs are same. Also, if you reinitialize with the default noise also, Gaussian noise also will be same. So that is the purpose of that. So I am doing this code, orange default. Then this is one of the zeros error 53,000 comma 1. So whenever you use some array, you fix the value size of the array. Here it is the size of the error is ERR is 53,000. So you fix it. You don't keep it open. MATLAB allows keep it open also. MATLAB allows. For example, you can write for k equal to 1 to 1000 r k equal to some some function, some computation, some variable or something. For example, it can be k plus 2 or whatever it may be, or k plus 2, say, or k equal to k plus 2, end. So here, you are not prefixing the size of the R. You are not prefixing. It is on the fly. Because it is k is 1 to 1000, R will have size 1000, comma 1, 1000 comma 1. If it is 10,000, it will have 10,000 comma 1. You are not prefixing. It will work in MATLAB, but the problem is this will be slow. It will be slow. Whereas if you fix R equal to zeros, 10,000 comma 1, you are prefixing. You are prefixing. You can use here RK, the same expression, no problem. Zeros will initialize with the zeros. 10,000 array with zeros. 0, 0, 0, 0, etc. 10,000. 10,000 into 1. So here you will be overrating on zeros, you will be overrating with kernels too. But this will be fast. This is fast. But if you don't initialize with zeros, if you don't prefix on the fly, if you try to decide the size, here you are deciding the size on the fly. For loop k decides up to 1000 means error will have 1000 by 1. If it is 10,000, it will be 10,001. It will be very slow. So better always prefix the array size or matrix size. You prefix it either using zeros or ones or some random. You prefix it. That is good practice. And another thing is, see, for example, how to use the size, how to represent variable. See here, bits per symbol. That is the variable. I am writing bits per symbol. Symbol stands for symbol. Bits per. This is self-explanatory. You don't use some z equal to 3 because even though z equal to 3, it will work. But we cannot understand what is z. But if you write bits per symbol equal to 3, whenever later if you use bits per symbol, you can search it. For example, you can search it. Can find bits. See here, bits per symbol is there. So you are using that variable. So because you are using long name, it is self-explanatory. If you just put z, you don't understand what is z. Though you can represent z is bit per symbol, z equal to 3. It is same. It will work. But for debugging, that will be painful. But when in your code, bits per symbol means yes. How many bits are there in every symbol? It is 8 PSK. 8 PSK modem. So bits per symbol is 3. That means 8 PSK means 3 bits per symbol. 2 power 3 is 8. If it is QPSK, 2 power 2 is 4. Bits per symbol will be 2. So constellation size base 2. Log of constellation size to the base 2. Log of 8 to the base 2 is 3. So bits per symbol, you can use oversample. I am using, for example, pulse shaping filter length. Pulse shaping filter length. That means pulse shaping filter length. I use long names to represent the variable. I am using a pulse shaping filter. I don't use L, simply L. L also can do, but that your mind won't accept that. Here it makes logical meaning. Pulse shaping filter length. Length stand for length. Filter stand for filter. Pulse shaping filter length. So you gives a long name which is meaningful instead of Z, K, X like that. Don't use such cryptic variable names. That will make your job of debugging very difficult. And somebody also cannot understand. But if you write pulse shaping filter length, somebody reads the code. Yes, they can easily say pulse shaping there is a filter is there. What is the length of the filter? What is pulse shaping filter length? Yes, it makes sense. It makes your job easy. Others also can easily understand the code. So better use long, meaningful names. But don't use very long, say 60 length or something. Because after some certain length, say 30 or something, I don't know what is the limitation of MATLAB. All other names, all other alphabets will be ignored. For example, this is assume that pulse shaping filter length is uh, maximum length. Pulse shaping filter is the maximum length. Pulse shaping filter unit and pulse shaping field length both it will treat same because it will accept certain number of alphabets. So you use longer but not very long so that it doesn't ignore certain last few alphabets. If you keep it long, after say 30, it may not accept. It will accept, but after 30, if there are two variables, 31, 32, 33 changes, variable 1 and variable 2, it will treat variable 1 and variable 2 same. So keep it longer, but not too much long. Make it more useful. Use meaningful variable bits per symbol. Delay, sample, match, filter. See, delay means we know what is the delay. A filter will have some delay. A sample, matched filter is sampled. Matched filter, that itself conveys the meaning. Matched filter. Sampled, delay. So, what is the delay of the matched filter, which is sampled? So, this conveys the meaning. Somebody debugs code or some other engineer looks into it, he or she can make easily. If you write L, capital L, they cannot make it. Even though you can mean, comment you can give L equal to matched filter length. That keeping in mind is very difficult. But if you use longer, meaningful variable name, that makes the code easily understandable and use more comments, generous comments you use. See, for comments you have to put this percent and in symbols is a comment. You proceed by percent. This is a percent symbol. In symbols is a comment. For example, this percent yearly 100,000. So this is a comment. Yearly 100,000 is a comment. You proceed using percent. This is a comment. And now I will explain how to set some breakpoint in MATLAB. For debugging, you should know how to set breakpoint. So, for example, at line 166, I am setting a breakpoint. At 166, you click the cursor. Cursor is there. See, at 166, cursor is there. Go to run. Single click, run at run. You single click, set breakpoint. This red dot, set or clear. First time it will set. It is set. Second time, the same point, if you click, it will remove the breakpoint. Second time it will clear it. I am going to set breakpoint. Set it is set breakpoint. I will run the code. Run. So at line 166, it has set breakpoint, it has hit. Channel out you want to see. See you it is a complex output. Channel output you can see. It is an array. Channel output is an array that you can see that actually. You can plot if you want, you can plot channel output, plot absolute value. It is complex. If you want plot absolute channel out, you don't have to type full channel out. CHAN if you type, if you press tab, I am pressing tab. Channel out, everything is whatever starting with channel, it displays. You want to plot channel out. You move the cursor, channel out you select, complete the brackets, absolute channel output, you can plot. This will help in debugging. This is how to if you want to debug the code, you can do it like this. It has plotted the absolute channel output in dot fig. If you want to zoom, go to plus. Zoom plus is there. Plus. Any portion you want to zoom, go there and expand that rectangle, leave it. It will zoom. It will zoom out. If you want to compress it, zoom in. Go to minus, click. Original complete figure will come. Zoom out and zoom in. You can save it. Of course, this I explained. Some name you can give. Channel out, absolute, dot fig. You can save it. I'm not saving it, but you can save it if you want. So we saw how to set a breakpoint, how to give the variable length. You keep it longer. See, for example, channel impulse response I give. That means it is impulse response of the channel. This variable name itself represent it makes meaningful actually. Chan for channel, impulse for response. It is nothing but channel impulse response. That full name I have given. So this is self-explanatory. A third person or another engineer can easily understand. Don't keep it X, Y, Z, all those things. So this is how to set a breakpoint. Another is how to catch errors. I will create one error. For example, constellation size is 8. Constellation size is 8. So I will copy it. I give just arbitrary command p equal to 1 over. I am editing this 1 over bracket constellation size minus 8. I am adding this line for to show how you can catch error. Since constellation size is 8, 8 minus 8 is 0, 1 by 0 infinity, it is an error. So it will, I am saving that. So constellation size I have initialized 8, 8 minus 8 is 0, 1 by 0 is infinity. So this is an error. So I have set the breakpoint at line 166, normal breakpoint. I have also set a breakpoint in case of error, pause on errors. I am clicking that actually. Pause on error means if there is an error, it will pause. So you can catch errors. If there are any errors, you can you can use this pause on error. If you want to remove, again you click it, it will go. So now you see pause on error has gone. So again you click it, pause on error will be there. So if there is an error, I am catching the error. It will stop further execution. Whenever there is an error, it will stop execution. So that I have feature I have selected. Now because the error occurs before line 166, it will break. It won't reach 166. It will stop before that. I am going to run this. Okay, I think this infinity it is not treating as error. For example, index, if it is index is negative, it will treat as an error. Infinity will keep another option. Pass on nan or infinity. That I am enabling. That also you can catch. Stop. I will click. It will remove that breakpoint. Now I run. Stop on pass on infinity. That see, pass on error is same. Error means index if the index of array goes to zero or negative, it will stop. Here it is not happening. I am artificially 1 by constellation size minus 8. It is infinity. So that if I want to catch pass on nan. Nan for not nan stands for not a number or infinity. So infinity will come. 1 by 8 minus 8 is 1 by 0 is infinity. So it will stop. See, at line 143, P is infinity, right? It has not executed that. It has not executed. 8 minus 8 is 0, 1 by 0 is infinity. It has not executed. See, this breakpoint it has not attained. 166, channel out you cannot see. Because before that, there is a nan or infinity. It has occurred. So you can set breakpoint if there is a nan or infinity or some warning messages. See, this will set pause on warning. If there is any warning, sometimes it may be logically okay, but it is not the correct practice. You may use some variable without initialization that is not correct. So such things it will give warning, but it will execute. Result may be unpredictable. So for on warning or infinity, nan for not a number, you can set a breakpoint. If there is an index, I'll show in another code. If there is a uh, how to use error. It is same as none. Pass on error, you click. Whenever index goes negative or zero, it will stop. So I will stop this. I will remove this program. This is a transmitter code. Another is receiver code I am using. So zeros, as I said, I am initializing because I want to speed. I don't want to, my things to be slow. So DFE feed. See this meaningful names. DFE is decision feedback equalizer. Decision feedback equalizer. So that coef means coefficient. It does makes a meaningful name. DFE feedback filter. The filter data. DFE feedback filter. Filter stand for filter data. This is a feedback filter coefficient. Every filter will have one data and coefficient. So I am initializing. Why I am initializing? Because inside a loop, without fixing the size, I am fixing the size. Without fixing the size, it will be slow. As I said, it will be slow. I am fixing the size. And I will show how to that error, how to catch error. So now pass on error is enabled. Okay. So here, for example, some multiple signal K. So varies from 16 plus 1024. Okay, we will see. Here some multiple signal K varies from 16 onwards. 16, 17, 18, etc. increment by 1 up to 1023. I just modify it. K minus 100 I will write. I make it simple modification at line 323. K minus 100. So when K is 100, 100 minus 100, 0. So this is an array. Index is 0. So this is an error. At 323, there will be an error at sometimes. Not k equal to 16. K equal to 16 also, yeah, k equal to 16 itself, it will become error because 16 minus 100 is negative. So first time k is 16 itself, it will give error, it will stop. It won't go further. There is an error. I save it. See, this is saving. K equal to 16. 16 minus 100 is negative. So 0 or negative index is error. So it will stop here. I don't set breakpoint here. Automatically it stops at line 323. See, I'll set a breakpoint here, 347, or here, 325. It won't attain 325. Before that it will stop. Because k equal to 16 itself, there is an error, so it cannot cross. Error will be caught and it can't come here. Even though I am setting a breakpoint, it won't hit this breakpoint. Set clear. See, I have set breakpoint here. It will not reach 325. It will reach 323 and stop because there is an error. Index becomes negative. But if I remove that condition, then it will hit here. I'll show you. I'll run this code. It will take a lot of time because reading from the mic. So it is running. Reading from the mic, it takes a lot of time. But here it doesn't, it is don't care because I am not using the mic. Of course, whatever speech I am speaking, that will take as a data. But sometimes it will hit 323. It don't come to 325. Just wait, it will take some time because I'm reading the mic input. I am through ADC, I'm reading that. I'll come to that and explain later. Of course, in the same lecture, I will explain that. But before that, let us see how the error it is catching. Because k equal to 16, 16 minus 100 is negative, so it will hit 323. It won't come to 325. See, 323 it has hit green, it is showing green, 323. Error in see, line 323 because index is negative, right? K minus k is 16. Let us type k. K is 16. 16 minus 100 is negative. This I made the modification. So index is negative, it shows an error, right? See error. Index is negative. Let us see what it shows. Line 323 it shows error. Because I have enabled the error actually, right? I have enabled the error, pass on error. But if you don't enable it, it won't stop. But you cannot see the variables. The advantage of enabling pass on error is, for example, multi signal. See, match filter out. You want to see, you can see that error has happened after that, but match filter output you can still see because it has not control has not been lost. Control is still there. It has not executed this line 323. It has not executed because there is an error. Without executing 323, it has stopped. You want to see the match filter output. I am showing just displaying that match filter output. If you want, you can plot it. You can plot it. Previously peak value. you can see any variable you can see if you use the error. Error has occurred, but before the error, the line where the error has occurred, it has not executed. But till before the error line, everything is intact, and you can see the variable as if the error has not occurred. You can see. But if you don't enable the pause on error, then same error message will come because negative, but you cannot see. For example, match filter output, now you can see. If you don't enable pause on error, you cannot see the match filter output. Now if you want, you can plot the match filter output. Plot absolute match filter output, MATCH. I don't type fully. I type tab. I press tab. Match filter out. It is coming. So I entered match filter output absolute. It will plot it. It will plot. See, it has plotted match filter output. It is meaningless because there was an error, and I have not given any data actually from mic. I have to give data, but this is meaningful data to the mic. So it has executed till 323. Now we can plot just showed you how to plot match filter output. Suppose I stopped this and I go to run, remove pause and error, pause and error, remove pause on nan or infinity. I removed. But whenever there is an error, it won't proceed further. But I cannot see the variable. That is the advantage of catching the error using pause on error. If you see now I am removed pause on error, I am running. At 323 it will stop, but we cannot see the variable. It will take time. So if you suspect some error, enable pause on error, you can see the variables without before the error has happened. Whatever has worked without the line containing the error, you can see all other line output, all variables you can monitor. So better enable the pause on error, pause on none or infinity. Better enable them, check them actually, put it, it will come as a tick mark. Now I have removed that. So error will occur because negative index, it will 16 minus 100 is negative, so it won't proceed further. But you cannot see the variable matching field output, you cannot see. Breakpoint, how to set breakpoint we saw. Just right click in the line where you want to see, move the cursor, using mouse cursor, you keep it within the line. Right click it, you can set breakpoint. If you click again, right, you can remove the breakpoint. Right clicking the mouse, you can set breakpoint. Again, if you click, you can remove the breakpoint. See, error has happened because k minus 16 minus 100 is negative. Error at 323. But what is the loss? Match is equal to output. Let's see. Some version you cannot see. I don't know. This is showing actually. Match equal to output is showing actually. Some version, if you don't click that, it is better to enable pause on error or pause on nan, pause on warning. But here it shows it without even clicking that, it shows. Some previous versions it was not like that. If you don't show, you cannot see match filter output. Now I am able to see actually. I don't know why. Plot absolute match filter output. So you are able to see that actually. I have closed the figure. I am running it. I am plotting again. You can see the maximum output, absolute value of maximum output. This is garbage actually because mic input we are not giving. So it is meaningless. But anyhow, I am plotting. But some previous version it can't plot. If there is an error, everything will become meaningless. But in this version, I don't know. If you don't enable pass on error also, it is working. So better enable it. Pass on error, pass on nan and all. So I want to remove the breakpoint. How to do that? 325, I have set the cursor, removed it. You want to set at 323. Keep the cursor at 323. I stopped it actually. 323, if you want to set a breakpoint, to the run, set clear, using set clear. Do it. Sorry, not right clicking, set clear. In run, set means it will set. Again, if you click, it will remove. At 325, you want. Keep the cursor, go to run, set. You do it again, it will remove that. Set again, set or clear. Second time it will take it as clear. 325 it is removing. 323 again set. Right. Set clear if I press or F12, it will remove the breakpoint. So it has removed the breakpoint. So I will remove k minus 100 because index is negative. It gave error. I will remove that. So error will not come. Now if I run it, error won't come. But I will show how to set a conditional breakpoint. Here in this 325, I am setting a breakpoint, normal breakpoint, not conditional. Set clear. Once it hits 325, it will hit halt. I will set conditional breakpoint k equal to 17. First time k equal to 16, conditional breakpoint will not be hit because k equal to 17 is the condition. 16 is not meeting, so it will go to the next. It will go. It will 17 whenever it is 17, it will hit. So anyhow, because of the conditional breakpoint, it cannot come to line number 325. It cannot come to the line number 325. Here there is no breakpoint. I will set a conditional breakpoint at 323. Set condition at 323. See, I have kept the cursor at 323. Go to run. Set condition. I want to k equal to 17. K equal to 17. 16 it started. K equal to say let us say instead of 17, 18. Two times it will run without breaking. K equal to 18. I want to set breakpoint. K equal to. That means K equal to 18 it will hit. Set breakpoint. This is yellow is conditional breakpoint. This purple is normal breakpoint. Yellow is conditional breakpoint. K equal to 16, it won't hit. 17, it won't hit. When it K equal to 18, because it is a for loop, 18, it will hit. I'll run it and show you. The variable name where you want to set the condition is k, right? K is the variable. If the value of k is 18, you want to set the breakpoint. So condition you type as k equal to 18. That means it is checking the condition whether k equal to 18, yes, no. First time k equal to 16, no, so it won't hit. Second, next time k equal to 17, it won't hit. Third time for loop, because of for loop, k equal to 18, yes, it will hit. It will stop. So it is running. Because we have not commented the mic input, it is taking too much time. It is a waste of time. But anyhow, this is good for explanation purpose. So this is how we should set conditional breakpoint. Because condition breakpoint I have enabled, it won't complete that and go to 18. I'll remove the condition directly, it will hit 325 without that. Next I'll run that and show again. I remove the condition. It won't hit here, it will go to 325 and stop. Now it will stop at 323 and at that you type K, it will show 18. Because K equal to 18 is the condition we set. How do you set that condition? Go to run. Sorry, let it stop, we'll show you. Yeah, it has hit. See, in continue, set condition. You click it, k equal to 18, you type. If you want 19, k equal to or whatever the variable. If it is n equal to 50, you can type. You can set the condition. Now it has hit. Let us see what is the value of k. It should be 18. See, 18. Because that is the condition we saw. See, set. Right? See, what is the condition we saw? Set k equal to 18. So here it is displaying k equal to 18. So when 16, 17 it is passed without hitting the breakpoint. When k equal to 18 it has hit. Right? So this is how you should select. See, suppose some problem you are, see, out of 10,000 you find that after 5,000 some problem comes. So after 5,000 some problem comes. Here you set a k equal to 18. You can say k greater than 50 you can give. Instead of this, k greater than or equal to 50 you can give. K equal to 18, instead of that k greater, k greater than or equal to 50, or greater than, simply greater than 50. So if you run it, when k becomes 51, it will stop. Whenever k becomes greater than 50, suppose you, for loop you need not increment 1, it can be 2. So 50 greater than 50 means 50 it won't hit. Next is 52, yes, greater than 50. 52 it will stop. If you put k equal to 51, it won't hit because increment is 2. 50 next is 52. It won't stop. So in that case, you can put k greater than 50. Any value greater than 50, it will stop. So this is a condition. So I am going to remove the condition. Removed it. I said okay. So that condition has gone, right? So I remove the normal breakpoint. I don't know. I would have set normal breakpoint. I click it. Sorry, I removed this breakpoint here. 323 was the condition. 325 was the normal breakpoint. I will set it here. 325 normal breakpoint. I'll stop it and run the program again. 323 it won't stop because the conditional we have removed. So no longer condition we are checking. So directly it will, when it will cross this, it will complete the loop and come to 325. Because we set the condition before completing the loop, it stopped because the condition was met. Now I remove the condition, nothing to stop. So directly it will come to 325 and stop. So I have stopped. I have removed it. I am running again. Directly it will stop at 325. I removed the condition. So sometimes conditional breakpoints are useful. When some problem comes after some value of the loop, you can keep the condition as the number of things which passes without any problem. 10,000 times it passes, yes, greater than 10,000 you give for the condition. The variable greater than 10,000 you give. Then it will stop if there is a problem. I mean, if the condition is met. Till 10,000 it will run without any your interference. Otherwise, every time you have to set breakpoint, you have manually you have to run. This you don't have to do it up to 10,000. After 10,000, 10,001 automatically it will stop. So you can use conditional breakpoint. Now 323 it won't stop because we have removed the condition. 325 it will hit. Now it is a normal breakpoint. So we saw how to set a conditional breakpoint, normal breakpoint, how to set, how to remove it, how to set pass on error, pass on infinity. Better you said pass on error, pass on infinity, etc. Because whenever there is an error, it will stop and we can analyze the variable. Earlier version didn't allow to see the variable. You don't pass on error, but this version allows. I don't know why. So there is no condition breakpoint. Directly it will hit. It will come and hit at 325 because this is an ordinary breakpoint. Once it hits the breakpoint, you can analyze. Now it has hit. So you want some multiple signal. It is an array. You can say plot absolute some multi signal delay, some multi signal delay, multi signal delay signal. You can give long name, meaningful names. You can plot them. So you can use a breakpoint and all the variables you can see. You have access. See, this is workspace. For example, match filter output if you want to see. Here in the workspace, match filter output will be displayed. Once hit breakpoint hit is hit M1OPQRS match filter output. See here match filter output. I double click match filter output. The array it will show. You can see the variable match filter output. You can see it is a complex array. See this is a match filter output 1, 2, 3, 4, 5, 6, 10, etc. You can see the complete array. If you want, you can plot it. You can visually see the array. Variables you can directly inspect. You can go to workspace. Whatever variable you want to see, you can double click on that and you can view the variable. So how to set breakpoint, how to set conditional breakpoint, how to catch errors using pass on errors, pass on infinity, pass on warning, we saw actually. Then these are all important things for useful for debugging purpose. Now I'll show you how to use the speaker and mic. Most of the code we will be using in hardware. We are going to use speaker and mic because we don't have access to sophisticated hardware, RF hardware and all. So we want because we have to shell out money for that. We don't have manpower also. So all our modems we will use instead of high frequency carrier 400 megahertz and all instead of 400 megahertz 1 gigahertz etc high RF carrier we will use low frequency audio carrier 1800 hertz audio carrier in our application modem application we will use low frequency carrier can be anything right the data frequency should be lower than carrier that's all data frequency is low then we can use any carrier audio we are using going to use audio frequency 1800 hertz or 1800 hertz as a carrier frequency. How to access speak? So I am going to remove that breakpoint condition. Set clear. I click again to remove the breakpoint. Now I go to transmitter routine. Here I am generating a 8PSK data, pulse shape it. I am not going to explain these things. These things will be explained during digital communication course, which I will be teaching later. But I am showing how to use speaker command, mic command, how to set breakpoints and all, which are needed for MATLAB, working with MATLAB. With any toolboxes or main MATLAB, you should know how to set and debug. This is a transmitter file. See? Yeah. So I will set a breakpoint at 182 passband real channel. I am using a modulator, 8PSK modulator. I am pulse shaping it. That means 8PSK complex data. I am filtering it. I am modulating by a See, if you don't understand all these things, it's okay. Don't worry. I'll be explaining in detail during digital communication. E power j 2 pi into 1800. This is complex exponential. 1800 is the carrier frequency. The baseband data I am multiplying by a carrier. So baseband data and channel output is the baseband data. I am converting into passband by multiplying by e power j omega ct. So this is the code. Don't worry if you don't understand, no problem. 1800 is the carrier. Okay. So I am taking the real of that. Why is that real? I will explain later. So passband channel output is the modulated data, right? So centered at 1800 hertz carrier, modulated data is there. See, in GSM and all, we will be using 800 megahertz, 900 megahertz, etc. Very high megahertz, gigahertz, megahertz, many megahertz of RF frequency. Here the RF frequency of modulation, carrier frequency itself is very low. It is in audible range. Below 20 kilohertz, everything is 20,000 hertz. Everything is audible. So 1800 hertz is also audible. But anyhow, the techniques are same. Whether it is audio range or RF, it doesn't matter because we are going to deal with baseband. So 1800 we are modulating. Real part we are taking passband channel output. Peak. I will explain why this is okay. Peak equal to max of this max command I already explained. Passband real channel output is the array maximum positive value it will capture and show it in maximum passband value real channel output it will capture and save it in peak, right? So at sound passband real channel output I am setting a breakpoint. I will set a breakpoint. Set clear set. It is set sound. I will explain how to use sound. I will also use pass on error. Pass on nan or infinity. Okay. Now peak. Here also I will set a breakpoint. I will show why I am using the peak command. I will explain that. I will run the code. Oh, okay. So earlier I modified it to show pass on infinity, right? So it has break the part. I didn't remove that. This is not okay. Nothing to do with my code actually. To explain, I wrote the added the line that is not okay. So I will remove that pass on error and pass on nan or infinity. I assume. Even though infinity will happen, it will pass on that and see. I removed the condition, so it ignored that. Even though infinity happened, I removed it. Otherwise, pass on infinity means it would have stopped. I removed the condition, unchecked it, tick mark has gone, so it has paused. Continue after the line peak. Okay, so it has not executed this 181. There is a break point. I am finding the maximum value of that actually, right? Maximum value. How I want to know how to use single step. Here is this is a step command or F10. F10 if you press, it will go only one line it will execute. Or step. You can click with mouse. I will use mouse. Step. Step is seen or F10. Then next line F10 or step. I will use click with mouse step. See it has executed peak. Right? What is peak? 0.66. So I am scaling by peak. What is that doing? I am scaling by peak. So peak will be scaled by sorry that passband real channel output. I'll plot first passband real channel output. Plot passband real channel output. I'm plotting. I'll plot it. See this is the real channel output. It is between zero point 0.6 to minus zero point 0.6. Passband real channel output. I will scale it and plot it again. Use hold down command. Hold down. Then I will plot real band channel. This time instead of blue, I will use red. red. I'm plotting that. So both are plotted in the same figure. See, red is masking because red is more. Blue is not seen because red has complete red. It has been masked by sorry, blue has been masked by uh, red. So you see only red. I'll do one small thing. Okay. Um, yeah. Why do I do this scaling? I'll explain later. Suppose if the peak is more, for example, to create, I'll add one line at 179. I'll add one line. 3 into 3 times the passband real channel output will become thrice. It will become higher magnitude. Okay. Now I'll run it again. So it at peak equal to this one max. It has hit breakpoint. I'll plot it. I'll plot it actually. Peak. I'll single stop F10. I'll find peak. What is the peak? Peak is 1.98 greater than 1. Just remember it is greater than 1. 1.98. I'll plot passband real channel output. Passband real channel. Default is blue. So passband real channel output it will plot. It is plotting blue. Right? See, it is greater than 1. Just see, it is greater than 1. Greater than 1. Right? Greater than 1. 1.8 or something. Large values it goes. Whereas the peak is 1.98. So, in our audio application, when you give to your speaker, you don't want you want the data to be within plus to 1 to minus 1. You don't want greater than 1 or less than minus 1. You don't want. So you scale by the peak. Suppose 1.98 is the peak. If you scale by 1.98, so passband real will be between plus 1 and minus 1. See now, see it is between almost close to minus 2 to plus 2. It is going minus 2 to plus 2. Minus 2 to plus 2. You want to keep it within plus 2, 1 to minus 1 because this is a condition required for dot wave files. I will explain why that is required. You want to scale down, you divide by the peak, then it will become plus 1 to minus 1. Now it is more than 1. It goes almost to plus 2 to minus 2. Minus 2. It is we don't want that. We have to restrict to plus 1 to minus 1. So we can divide by the peak. Now you have plotted. Now I will single stop again. I am dividing by the peak. So now I plot it again. It will be between plus 1 and minus 1. I give red. See red. Same passband real channel output, it is still scaled because I divided by the peak. Instead of 2, it will become low value, plus 1 minus 1. See, red. Oh, I didn't use hold. Okay, I'll run it again. Sorry. I didn't use hold. So it plotted separately. I'll run it again. Now, I'll plot it. This greater than 1, between plus 2 and minus 2. I'll hold on. I'll single step. I am scaling. I'll hold on. I'll plot both. Hold on. Now, scaled one. Before scaling, I have plotted. Plot passband real. This one. Before scaling. After scaling. Before scaling, it was between plus 2 and minus 2. After scaling, it will become plus 1 and minus 1. Because earlier I didn't use the hold on command. Now I am plotting again. The same plot. See, red. After scaling, it has become between plus 1 and minus 1. Earlier it was between plus 2 and minus 2. Why do we need this scaling? Because for our mic and speaker, we should use dot wave file, not MPEG or MP3 or MP4 format. They are compression. They use compression. We don't want our data to be compressed. We want linear format. Linear format. So linear format means dot wave file we have to use. Dot wave is the extension. So for that, input data must be between plus 1 and minus 1. Because the data can be larger, I scaled by the peak so that this blue, it was minus 2 to plus 2. I scaled by peak 1.98. Now the data has come from minus 1 to plus 1. This is after scaling. Red is after scaling, blue is before scaling. This we have to do it. Otherwise, it will clip the data. After 1, it will clip. 1.2 also it will become 1. 1.9 also it will become 1. So it will clip. Then it will cause distortion. We don't want that to happen. So we scale it so that our data is within plus 1 and minus 1. Without scaling, the data can be 1.8, 1.7. So anything input data, so it will clip it. It cannot take more than 1. So 1.7 it will take it as 1. That means there is an error, right? 1.7 becomes 1. It is an error. It is clipped. So that causes distortion. We don't want distortion. So we scale the input before giving to the speaker, scaled by the peak. So input becomes between plus 1 and minus 1. We have scaled it to the maximum dynamic range of the speaker between plus 1 and minus 1. This we will give to the speaker. Okay. So now what is the use of max? That peak command. We scale that maximum by the maximum value so that input data is between plus 1 and minus 1. This is required for all dot wave files and also the speaker input. It cannot exceed 1 or minus, it cannot become lower than minus 1. Now we have scaled value between plus and minus 1 passband real channel output. We will give to speaker sound. This command, note down sound variable name. Passband real channel output is the variable name, comma 9600. 9600 is the sampling frequency of the DAC, DTA converter. 9600 hertz is the sampling. You have 19.2 kilohertz, 19,200 hertz, or 48 kilohertz, 48,000 you can give, whatever. There are some restrictions. You cannot give 5,400 and something like that. Arbitrarily value you cannot give because Windows doesn't allow any sampling rate. It allows certain rates 19.2 kilohertz, 9600 hertz, 48 kilohertz, all those things they are allowed. So 9600 hertz sampling frequency we pass this pass channel real channel output to the DAC. We are fine passing at 9600 hertz rate sound. We will single step this. You will hear sound. See, listen. Yeah, I am playing the data, passband data to the speaker. That is the sound you heard through the speaker. Speaker also you control using MATLAB. Sound bracket variable array name, comma sampling rate. There is a format. Sound variable array name, whatever variable you want to give to speaker, array buffer name. That is passband real channel output, comma 9600. 9600 is the sampling rate. Sound, that is the format. But for this, use sound. You need the audio box tool. Without that, it won't work. Okay. Suppose you don't have the audio tool, you don't want to spend money for that. How to overcome that? That is tedious, but still you can do it. It is tedious. How to do it? Help. And type help. Audio right. Audio tab. Audio, so many things are coming. Audio rate is there. Help audio rate. Audio rate is a command. Buffer is, what is the buffer? You want to write into audio file, passband real channel output. You can store the buffer into a dot wave file. File audio write, file name, buffer name, sampling frequency, right? Fs is sampling frequency, Y is the buffer. In our case, it is passband real channel output, modulated real data, because we are using the real of command. Passband data, don't worry if you don't understand, no problem. I'll be explaining this thing in detail later. The modulated passband data is the Y value. File name is some name. Transmit samples, TX samples you can give, dot wave. Dot wave you choose because you don't want to compress the data. You want linear format. Linear format is possible only for dot wave files. Even though it supports MP3 and MP4 and all, don't use them. That will compress. That will cause additional distortion. So dot wave file, audio write, file name, array name, sampling frequency. Forget about all these others. File name, buffer name, sampling frequency. For example, audio write, file name I will give tx sample dot wave within quote. Then buffer name is passband real channel output. I press the tab, it has come completely. Passband real channel output. I want to write into tx sample wave, comma. I want sampling rate at 9006. You have to tell the sampling rate. Otherwise, it will take the default sampling rate. You don't want default sampling. That could be anything. We don't know. Don't use default. Your own rate. At what rate I want to sample this signal? 9600 hertz. I want to sample. Passband real channel is the buffer data. I want this to be sampled at 9600 hertz and fed to the DAC, and DAC will go to the speaker. So TX sample dot wave. I press semicolon and enter. See, it is saved in TX sample dot wave. I'll put dar start dot wave. See txsample.wave it is showing. So in txsample.wave it is saved the data. Sampling frequency is 9600 hertz. It is sampled. Why this is required? Directly I use the sound, because if you don't have the toolbox, audio toolbox, you don't have to do sound command. Passband real channel output you save in a audio file dot wave file. Then using VLC media player, you run the dot wave file. You can play it, right? Any dot wave file using VLC media player, you can play it. That speaker output will come through the media player, VLC media player. It will come. That will transmit. So you don't need the toolboxes. But I have bought it because this makes my job easy. Otherwise, you have to save it, run the VLC media player separately. Then mic also, you have to use recorder, capture into recorder separately. Then instead of audio read, write audio read. That dot wave file you read it, then processing it. So you don't need audio toolboxes, but it makes your job very difficult. You have to save in the audio file, play using VLC media player, capture using Audacity is a software where you can capture dot wave or linear format using Audacity. You record that and dot wave file you feed your the receiver, you feed that dot wave file. You can do that. But instead of that, now I use the sound command. It will give sound. I will show you the receiver file. Sound will be coming from the speaker. Receiver also you can run. For example, receiver. This is a receiver file, right? See, this is the receiver command. See, at 205, this is a receiver file. The DV reader, audio device reader, 9600 into 5, that is 48,000. Command 9600. What does it do? You just see this command, this is more important. These things you have to be familiar. This you see. 9600 into 5 is 48,000. 48 kilohertz or 48,000 is the sampling rate. I told you 9600, 19.2 kilohertz, 48 kilohertz, all it is supported by Windows 11 and this MATLAB. So You are sampling at 48 kilohertz. What is the length of your buffer? 9600. At this sampling rate 48 kilohertz, 9600 data are read, right? So record down reader reads 9600 length buffer at 48,000 hertz sampling rate, reads the data of 9600 and saves it into this, right? 9600 plus 1 to k plus 1 into. So I write into different buffer. One buffer k equals 0, one buffer of 9600. Then next data record I read it, I put it in a for loop. Next to 9600 samples I read, I put into consecutive. It is a large buffer, consecutive buffer, right? 1 to 9600, 9600, 1 to 9600 into 2, like that it will go. So it will, I write into a large buffer, right? How many times I write? 500 times, because k is going from 0 to 500. So 5000, 5000, sorry, 501 time I will write. Each buffer is 9600. So one single buffer of 9600 into 501, it is created and the data is written on that, right? So data is written on that. See, for example, see here, I have prefixed 9600 into 500 receive input. So this I have told earlier. Without this line, it will work. No problem, it will work. Because runtime it will increment the index, but it will be very slow. But if you prefix the size 500 into 9600, only that many samples will be taken. It will be fast. So always prefix the size. Don't keep it as loose. Don't fill it in the real time. Then it will be slow. It will work. It will be very slow. So you put into a buffer, large buffer. Each one will be differentiated by 9600. 1 to 9600, 9600 1 to 19,200, etc. It will go, right? So I have saved in the buffer. This overrun is a feature used in MATLAB, because sometimes when you save, it may skip some few samples. We should not skip any sample, then it will cause problem. Because your processor is slow, it may not take samples, all samples. But here it does. I checked it, never overruns. So no problem. But overrun is a safety feature. You cannot see after 9600. You cannot say skip 9601 and 602. You cannot skip and go to 9603. You cannot go. Two samples, if you skip, it will cause error. Your algorithm won't work. So you should not overrun. So you know how to use MATLAB command, right? For this is for my command. You want to dev reader, audio device reader, sampling rate. First is sampling rate 48,000, 9,600 into 5 is 48k. Sampling rate, comma, buffer size. Then use this record dev reader. Put it in the array, right? Array 1 to 9600, 9600 1 to, then again 9600 to 2. So array will grow by 9600. How many times? 500 times. 501, sorry. It will come out of that. Once it is finished, large array will be initialized. You are saving it a large array. So we saw how to use speaker, how to use mic. If you don't have speaker and mic, you can use audio, right? VLC media player you can play using Audacity. Using Audacity, you can record in dot wave file that you can feed audio read. You can feed audio read. That is very difficult. You can do it. If you don't want to buy the audio toolbox, you can do it, but that is painful. Every time you have to record, then using Audacity, you have to play the VLC media player, then record it, then you have to feed the audio read. Using audio read, you have to read the file. This is painful. Directly you can use mic and speaker using MATLAB itself. if you have the audio toolboxes. That's why I recommended to buy audio toolboxes. Right. Now we saw how to use speaker, how to use mic, how to set breakpoint, how to set conditional breakpoint, how to clear it, how to catch error and using breakpoint on error, breakpoint on infinity, nan or infinity. We have seen all these things. So we have more or less we have completed whatever required for MATLAB. If anything later if somebody points out, I can explain. But most of the basic commands I explain, not all basic commands I explain with this lecture 5 MATLAB. I showed how to see the variables, right? How to see the variables. You can workspace. You can double click on the variable name. You can see the content. You can plot everything. Is possible. Now I explained. Okay, I remove that condition. Transmit. We added the code. Forgot where I added. Anyhow, I'll do it initially. So with this, all the MATLAB commands ends. Okay.